but there is nothing like this is very tough. Okay, so all you need are the basics. Okay, and here at Radical Academy, that's what you normally do. We give you the fundamental of everything, whatever topic you wanna learn. We give you all those basics, and we go into the deep details of things like that. Okay, but our main thing is to help you understand at the fundamental level. Because once you get some of the key concepts, fundamentals of everything, the subject, the topic, you are just going to be so crazy that you'll be able to the subject which you claim that it was difficult some time back. Okay, but yeah, so why don't we jump into this topic? Okay, so it's empirical formula, guys, and welcome to my channel. This is Radical Academy. Please, if you're new to this channel, please remember to subscribe so that you always get the notification from my YouTube, okay, that we have posted a new video, and you'll be the first person to get all these latest posts and updates from our channel. Okay, so don't forget to subscribe from our YouTube channel, which is just Radical Academy. If you're watching from Facebook, please, it is just Learn with Professor Wadia. So yeah, so that's the thing. So now let's dive into this thing, empirical formula. So we begin by definition. What is an empirical formula? Okay, so I want to begin by saying that chemistry is very simple. Chemistry, I don't know, but here's the thing, okay, because science is about things that we normally see around us, things that we normally interact with, the oxygen that we breathe in, the carbon dioxide that we breathe out, everything is around us. And chemistry teaches us how we can begin to, understand the world we live in, okay? But nevertheless, what is an empirical formula? So an empirical formula is just a formula which shows, the combination of atoms in its simplest form. Okay. So this is okay, so that's basically simply the definition of what is an empirical formula. So an empirical formula is the formula that shows how the atoms are combined in their simplest form in terms of atoms, okay? Or if you just like in their simplest form, okay? So that's the definition of what an empirical formula is, okay? So in this video, we are going to see how you can be able to come up with or just, determine the empirical formula of a compound, okay? So, by the way, I'm going to give you an example before we get to the actual real example of what an empirical formula means and how you can comprehend and understand what is an empirical formula. So just stick around and let us move together, okay? So for example, okay, so each one of us knows about carbon dioxide. Most of these are basic compounds or elements. We all know them, okay? Now, I want to share with you this compound, which is a very toxic compound to us human beings. But okay, so now let us look at carbon dioxide. How is carbon dioxide formed? Okay. So I'll give an example of these two dusts, okay? So let's imagine that the small dust is maybe, oxygen, and then the bigger dust is carbon, okay? So now let's see how the combination comes in, okay? So I hope and believe that you do understand when you talk about the concept of a chemical reaction or chemical combination, how compounds or other single substance or elements are formed, okay? So, but anyway, how is carbon dioxide formed? Okay, so we have carbon plus the oxygen gives you carbon dioxide. Okay. So it's a simple chemical reaction that the carbon and oxygen, and in fact, by the way, this is what we call, a combustion reaction. When anything burns in oxygen or any substance reacting with oxygen, that's gonna actually give us carbon dioxide. Okay, so carbon dioxide is a toxic gas that comes out most of the time if there is insufficient oxygen in most of these car engines, or there isn't enough fuel. If there isn't enough oxygen or sufficient oxygen, so you end up getting what is now called the carbon monoxide. So carbon dioxide is a stable compound, okay, but it is just toxic to us human beings. Okay, now, so this is some kind of a weird equation to say, but in chemistry, everything should be chemically representable, so it should be that, and then, okay. So that's carbon, that oxygen, that is now carbon dioxide. Now, when you're talking about an empirical formula, you're simply talking about what is the combination of these, the oxygen as well as the carbon. What is their combination? Now, the thing is this, okay? When you look at the carbon dioxide, okay, you can see that the oxygen has got 2 as a subscript number, and then the carbon doesn't have any number, but with that you can say the carbon is just 1, okay? So the way in which these two elements are combined is what is normally referred to as an empirical formula. So an empirical formula is just the way in which, the formation of compounds, and then those elements involved in the formation are combined, okay, in their simplest form. Okay, so you can see that this is the simplest form of carbon dioxide combination, or just a carbon and oxygen combination. But again, when you look at that one, so when you look at the ratio, when you look at the ratio of combination, is that we have the carbon to oxygen, and then now the carbon, since it doesn't have any number in its chemical formula, then you just write 1, and then now the oxygen does have a number that is 2 as a subscript number, and then we write that, okay? And this is like the ratio of combination. Our elements were combined, so they were combined in the ratio of 1 to 2. So now, but we want to actually do something different other than just writing a theoretical formula which is already established, okay? And that's how now you can easily begin to understand empirical formula. So empirical formula is very cardinal where new compound has been discovered, like for example, hematite or magnetite, things like iron, and these complex compounds, okay, have been discovered, okay? So we want to know their chemical formulas or chemical combination, okay? Okay, so I'll give an example. So let's say, for example, let's say we have the physical substances, okay? And then, example, if sulfur is equal to 32 grams and oxygen is also equal to 32 grams. Okay, So now let's get a simple example. Okay, so let's say for example we've got sulfur and also the oxygen. Okay, just like we had before, carbon and oxygen, and then we saw how the combination came out. But now, what if we have been given maybe a certain actual measurement of sulfur, which is 32 grams, and then oxygen, which is also 32 grams. Now, let's see and begin how we can now come up with something like that, okay? So, I'm going to show you some of the steps, or rather the procedures that you need to take so that you can now understand how the formula is going to be, or what would be the simplest number of atoms possible in terms of combination. Okay, so what you do now is that I have written the actual question on the board. These are now it's like experimentally determined that 32 grams of sulfur combined with 32 grams of oxygen to form an oxide. To form an oxide of sulfur, what is its empirical formula? Okay, so what has been happening is that you measure the mass of sulfur, you measure the mass of oxygen. Now, let's say for example we want to combine these two elements. Now, what could be the formula, the chemical formula in the form of empirical formula, the simplest combination of the atoms? Okay. So what you do is, I've got a table that I've written down. So in this table, we are saying that elements that combine is sulfur and oxygen, and then also mass. Okay, so the mass that combine, so is that now filling up? The mass that combine is 32 grams. So this one, sulfur. And then for oxygen is also 32, okay? And then relative atomic mass, okay? So what you need to understand about that relative atomic mass, okay? So about relative atomic mass is that when you get the periodic table, you discover that for oxygen, it has 16 and then 8. For sulfur, I think it has 32. Okay, 32 probably. Okay, so now when you're dealing with this, okay, so you use the number at the top there. Okay, you use this number. Okay, so relative atomic mass, it is the number when you go on the periodic table. Those numbers at the top of each and every single element is normally referred to as relative atomic mass number, or just the mass number of an element. And when you come to this table, relative atomic mass of sulfur is 32, and then also for oxygen is 16. Okay. So what you do there now is that you come to moles of atoms that combines. So what you do is you get this mass, then you divide by this mass. Okay, so you are going to get 1. And then what you do also, you get this mass, 32 over 16. You are going to get 2. Okay. And then you come to this part. Come to this part now. The ratio in which atoms combine. So you just get this one. You put 1 to the ratio 2. Okay. And then empirical formula becomes, you write now the symbol of sulfur is S. The symbol of oxygen is O. Okay, and then you just say S1, then O2. So S1, O2. Okay, so that is the symbol there. Okay, so S1 means sulfur, there is just 1. you write the one under, and then the oxygen, there's just 2, you write oxygen and then 2 there. Now, sulfur dioxide, because we have 2